Okay, so let's talk about several things. First of all, we're coming up on spring break-ish, and midterm grades have to be in. So we kind of have two options. We can do an exam after spring break, which means you have time to forget everything, or we can do an exam before spring break. So what I went ahead and did is I made a online exam. So I did a couple of things. Usually my exams are 10 questions. You have the time in the class to do it. It's closed book, closed note, closed neighbor, closed all that stuff. The exams are pretty applied, so not just memorizing stuff necessarily. But since we are kind of need to stay on pace with our homework assignments and we're a little bit behind on catching up with material in class to the homework assignments, I'm going to strategically do something here. So I made the exam an online exam. It'll be up following class today at 11. It's not due till midnight on Sunday. I'm going to give you a class period on Friday to do it, so the exam doesn't have to take any of your time outside of class. If you want to do the exam during the class period on Friday, you can do that. I also moved the assignment that was supposed to be due on Friday to also be due midnight on Sunday. So between now and midnight on Sunday, complete both of those things. All right, so you figure out how you want to time manage things. So let me talk about the exam a little bit. I posted some stuff about it up on Slack last night. But generally speaking, this first exam is going to have less programming on it than the second exam. And remember, I have a policy that if you do better on the final exam than you did on the midterm, I'll replace whatever you get on the midterm with whatever you get on the final. So having said that, the final is typically, quote, harder than the midterm in that it's more programming and less background information, history of languages, that kind of stuff. Go ahead.
The midterm and the final, are those the only two exams?
Only two exams. Yep. So you basically get a do-over on the midterm if you do a poor job on it. All right. So if we I'm just going to run through our slides here leading up to where we are today, and kind of maybe point out the highlights, things that you should focus on for the exam. From the programming perspective, I think there's 4 questions on there that are programming questions. 2 of them have you do something. The other 2 have you read code and tell me what that code does. For most of you, you should be more comfortable right now seeing a solution and telling me what that does than being able to just sit down and write code from scratch. If that's where you are right now, you're exactly where you're supposed to be. Remember, right back to day 1 of class, programming is like a sport. You're supposed to feel like you suck at it right now. All right, so if you're discouraged, you feel like you're spending a bunch of time and not accomplishing a whole lot, or the only way you're getting your homework done is in groups, that's the goal. That's why teams practice as groups, and that's why it's okay to suck at practice so that when you get up to the big game, you have a little bit more practice. And, things are going to get harder and harder as you progress through the classes, 200, 250, 300 for the programming classes. But what you should feel is that by the time you get to, let's say, 300, the third programming class, the assignments will be way harder, yet you'll probably actually feel like they're not quite as complex because you're a whole lot better at playing that game than you are right now. So right now you're solving these little tiny problems and it's taking you forever. You'll spend that same amount of time later on writing kind of like a whole video game or something like that. All right, so you will see your skills improve. I promise one day it'll just kind of click for you where things will start making sense. So if you're very lost right now, very confused, very overwhelmed, you're exactly where you're supposed to be. I would say when you see a solution, maybe minus the solution from last class, because that one is arbitrarily more cryptic, I think, just because of formatting stuff, but I put up an alternate solution to it. But in general, if you see a solution in class and when you see it, it makes sense to you, you're probably in a pretty decent place. Make sense? All right, so having said that, 2 of the programming questions will be, here's some code, tell me what it does. The other programming question, two programming questions, really have you work with collections. Be able to write loops, be able to create a variable, be able to do something with a string or do something with a list. And for the exam, the do somethings are not going to be extremely complex do somethings, right? You're in a timed situation, you're not going to be able to sit there with your group and brainstorm some stuff. That doesn't mean it's not going to be maybe difficult for some of you, but it is a significantly simpler type of logic that you will need to do on the exam, as long as you can loop through every element of a list or loop through every element of a string and do string concatenation stuff, those types of things. That make sense? All right. So that covers kind of the programming stuff on the exam. Now I'm going to kind of spin through the slides here pretty quickly and point out highlights. I'm not a big fan of memorization stuff. So for instance, when we start looking at, I think it would be very wise of you to have memorized this slide. Hint, hint. All right, so that will cover one of the questions on the exam. All right. And understand how all programming languages map to how human beings solve problems. That's a core tenet of how you learn programming, and having that in your back pocket is a good thing. All right, but like memorizing this slide, the whole history of languages and stuff like that, this is something I want you to appreciate and understand how we got to where we are today, but I'm not going to ask you some detailed question about, to like reproduce this chart or something like that. It created a foundation for us to build everything else on top of, but it's not something that I'm going to, so I wouldn't spend time memorizing this. I won't ask you about that type of thing on the exam. Make sense? Same thing here, again, foundational information. Not that it's unimportant, but we're building your knowledge on top of this foundation. You should probably understand kind of the details surrounding Python specifically, that, it's an object-oriented language, which doesn't mean much to us yet, so that's probably not something that's going to be covered on this exam, but it'll be covered heavily on the next exam. But certainly the idea that it is a interpreted language, what it means between an interpreted and a compiled language, the idea that it's a loosely typed language as opposed to a strongly typed language. Understand those concepts, understand where Python fits into the world. I'm a big fan of number conversion stuff in every single class. My 450 students are still doing number conversion stuff. In fact, 450, we're writing an operating system, and almost everything we do in there is either in hexadecimal or binary to begin with. So the fact that they've had all these years of number conversion stuff is very beneficial. So I should be able to, on the exam, give you a number of bits or a number of megabytes or something like that, and ask you to convert it to any of the other things. Similarly, I should be able to ask you to go from one base to another base. Guarantee there's going to be conversion questions, not just on that exam, but every exam you ever take with me in any of my classes. Even if conversions have absolutely nothing to do with the course, there will be one question on conversion in there. It's a really powerful thing that computer scientists should have access to. Concept of a pointer, certainly. This idea of a memory address. Mostly as it pertains to lists. When we pass a list to a function and we make a change to that, that change is permanent. It has side effect. This slide is important, but since we're only working with a high-level language in here, it's good to kind of know where Python sits relative to the CPU, but not something I'd probably directly ask you a question about. But we should understand that Python is a power tool that makes programming, quote, easy for humans, as opposed to if we were writing in zeros and ones. So all the times you're working on your programming assignment and you feel like these are taking too long and it's more complex, you're always introducing errors, just remember it could be worse and you could be tapping out zeros and ones. And again, I promise that you will get better. we're kind of getting to that point where everybody's getting a little stressed out as we're getting to midterms. So I'm getting a increasing volume of people concerned that they're just not getting it and programming is not for them and that kind of stuff. I promise you're exactly where you're supposed to be. If you can answer yes to that question of when you see an answer, it makes sense to you, but you don't necessarily think you could just have sat down and written it on your own. That's where you should be. Okay? I know it sucks. I know it sucks to work really hard on something and then feel like I'm not getting any better at this. I promise that it'll eventually click. I've been teaching this for 20 years. You don't just learn it overnight. Okay? So, and keep in mind that I understand that. So when I grade things, you probably have noticed that you will turn in something that's not that great for your programming assignment and you get an arbitrarily significantly higher grade than you probably deserved based on solution. But you put in the time, I saw you worked with groups, things like that. That's what I'm looking for. I'm looking at your stuff as it progresses. And those of you that are saying that, you struggle with this assignment and you said the same thing with 3 assignments ago, the more recent assignment's harder than the one 3 assignments ago, and you're struggling kind of at the same level, which means you're actually getting better. Things about the CPU, I won't ask that directly. Again, this is foundational information. We want to understand who we are actually talking to when we write our code. We should understand the idea that Python's an interpreted language. That would be fair game. So if something is contextually relevant to Python specifically, when you go through these slides, that would be, I would call it fair game. I'm going to focus on Python, programming fundamentals, and some initial programming skills. Certainly be able to work with integer division and modulus. Understand the idea of getting doing division as integers and getting the remainder from integer division. I won't ask anything about, remember we did this little thing about bitwise XOR foundational stuff, more kind of giving you the information when you are writing code and you get an answer, but it's not the right answer. Those are sometimes the harder things to debug because it's much friendlier when the interpreter just screams at you and said you wrote something wrong. It doesn't work as well when you write something and it works, but it's not the answer you expected. So that's why I covered this, but I won't test you over this in this course. Certainly be able to define variables, be comfortable with some of the built-in functions that we've worked with, converting something to a string, converting something to an int, be able to create Boolean expressions for asking questions and for creating loops. You should be comfortable with the not operator as well. Be able to ask questions. Be able to write a function. We're kind of at the point now where we're right on that cusp of whether I'll say write the code necessary to do something versus write a function that takes in some number of parameters, and either a focus area for the exam is know the difference between returning a value and printing a value. Those are different things. Printing means it'll display something to the screen, but we don't necessarily get it back to use it in a different part of our program. Returning a value means you get it back and you can do something else with it. All right, those are distinctly different things. So understand functions and the purpose of those guys. So here's all our number conversion stuff. And then focus on the things we've been doing more recently, dealing with collections. I won't ask anything about regular expressions on the exam. That's the stuff for today. I'm going to talk about that today. And I want to give you some more background on it. That's what I'm kind of saying. We're like a half a class behind for me keeping the content rolling, so I'm going to try to play catch up with that and give you a little bit more runway. I'll look at the assignment due on Monday and see if I can combine the Monday into the Wednesday one, so you don't have an assignment due Sunday and Monday, because I want to catch up on content in class, so we're not dragging a half a class behind. So let me address that. You can plan on not having an assignment due on Monday. We'll do something with it. Okay? Understand how to get the length of a collection, the number of characters or number of elements inside of a collection. Be able to index it. Get bucket 3 of a string, get bucket 4 of a list, those types of things. Understand dictionaries as well, but the focus on this exam will be less about dictionaries and more about working. I'm kind of focusing more on the fundamentals. And even though dictionaries are collections, they are different, right? We did the little game inventory thingy, which kind of gave you some practice with dictionaries. And dictionaries are going to be a powerful thing as we move forward, especially as we start transitioning into classes. But at the same time, I would say that the focus for this exam is get very comfortable with strings and lists. Okay? Understand what a dictionary is in terms of being a collection of name-value pairs, but you don't need to necessarily focus on the specialty loops for going through and getting both the key and the value and that kind of stuff. I'll be pretty happy if you're really solid on strings and lists. All right? I'd rather come in on Monday and have us solid there and have us revisit dictionaries later on than maybe muddy the waters with dictionaries, since they're a little bit different than strings and traditional lists. Know the continue keyword. I wouldn't ask you to write something that uses it because, like I said, you're going to be doing simpler logic for the programming things, but it would be fair game if I gave you some code and say, what does this do? I should be able to use continue in there, where it just skips the rest of this iteration through the loop and goes to the next iteration of the loop. I don't remember if I used one of those or not, but it would be fair game for me to show you something with that. Definitely understand the scoping rules. Hopefully we've clarified that. We've harped on it the last couple of classes, and we had our little chart here with the yellow box and the red box. And then last class we decided we were going to start bringing everything into a function called main, where your program will run off of, so that keeps our variable scope separate, so that we don't have this idea that, I can just create a variable and it's accessible everywhere. We want to steer clear of that idea. So understand what variable scope means. Same thing with variable passing. I referenced this a few minutes ago. If we pass like an integer into a function, we're passing it by value. So if we make changes to that, those changes are not permanent. But if we're passing a list to a function, it's passed by address, passed by reference. So if we make modifications to that list, those guys have side effect. Those modifications will be noticed outside. We drew some pictures about, pointers in memory, where if I have a global variable A or something in main called A, and I pass it into a function, into a parameter called a list, both of these variables point to the same place in memory. So if I make changes to a list, those changes will be noticed when we exit that function, and now I can still get to that same place in memory through the variable A. All right, so whenever I'm working with a memory address, I'm changing it in the actual thing. Our example in class, I think I said something along the lines of spray painting my garage door. If you have the address of my house and you spray paint my garage door, I'll be surprised when I get home, right? Or if I give you a copy of a quarter and you go and melt the quarter down, it's not going to impact the quarter that's still in my pocket. It doesn't have side effect. All right, work with strings. The in versus not in for collections. Going through every element in a list, going through every element in a string, be able to read and write that. I don't think I'd ask you any questions on the exam where that would be required. I think you could always, in fact, almost always, you could just write a loop that goes through and you just index the elements of a list rather than getting each element of a list using the in instruction. All right, so questions about the exam. You can take it starting following class today. I think it automatically will release at 11 a.m. or something today, and it will disappear at midnight on Sunday. But when you sit down to take it, you have to take it all in one sitting. If you have an hour to take it, that should be plenty of time. 10 questions, short answer, no multiple choice, no true false, just either write some code or answer a question with a sentence or two, something like that. All right, questions on that? Okay, so let me cover this for a few minutes, tie up some loose ends from last class. When we look at, so like I mentioned last time, this idea of having a list of lists can be a little intimidating, even though when we think about a list, so let me, let's just create a slide here and say we have a list is a collection of things. That's what a list is. Where a thing can be anything that Python supports. Make sense? That means we can have a list of integers. We can have a list of chars. We can have a list of strings, which are collections in and of themselves. We can have a list of lists. Or in this case, we have a list of lists of strings. So we actually have a collection that holds collections, each of which element is in there is a collection in and of itself. It looks more complex, but it's still just a list of things. Bucket 0 of table data, this guy right here, is this thing. That is the thing that lives at bucket 0 of table data. This is the thing that lives at bucket 1 of table data. This is the thing that lives at bucket 2 of table data. This is the thing that lives at bucket 0 of the list that lives at bucket 2 of table data. Because the element, the thing that's at bucket 2 of table data, happens to be a collection. And collections can be indexed from 0 to the length of that collection. Okay? So if I wanted to access this last, that thing dog there, I would say table data at bucket 2. That gets me the collection of dog, cats, moose, goose. And then I can say, give me bucket 0 of that collection. That will get me dog. And then to make things even scarier, I can say, give me bucket 1 of the collection in there, which will be the O. Okay, bucket 1 of dogs is the character that lives at bucket 1 in that string, which is a 1. Does that make sense? So this is not some kind of special, crazy, you need to memorize syntax in Python. I just happen to have 3 collections here. I have a top level collection that allows me to get bucket 2 of that guy, and bucket 2 happens to hold a collection. And I can get an index of that collection. So I can say, give me the thing that lives at bucket 1 in that collection. That guy happens to be a collection, happens to be a string. I can say, give me bucket 1 of that string, which will give me the O. Does that make sense? So break it down into the generic. Try not to get yourself caught into this trap where you see something like this and it immediately looks complex. So you immediately get intimidated. Instead, think of collections are collections of things. Then ask yourself, what kind of things are they? And what can I do with those kinds of things? Make sense? That will open up the kind of focus you in on which tools you have available to you. Okay. So let's talk about regular expressions, the stuff for today. And I actually went ahead and I wrote out the solution so we can, again, play a little catch up, and we'll talk about that. Then I'll introduce the stuff you'll need for the assignment for Sunday, which actually isn't substantially more. Regular expressions are actually really cool. All right, so based on the reading for the assignment for today, what can you tell me, what are regular expressions? What do we use them for? Go ahead.
Storing patterns.
Okay, why would we want to store patterns? What's valuable?
You can search a word for patterns that are matching.
Okay, so for instance, if I showed you, if I gave you something that looked like this, what is that? That's an email address. How do you know? It looks like an email address. It follows what you know is the pattern of email addresses, right? All right. If I say something like lol.docx, what's that? What kind of file? Word file. Okay. How do you know that? It follows your known pattern of what a Word file looks like, right? Okay. It's kind of a file name followed by a little extension. That extension, you might not have every extension known to man memorized, but you know a bunch of them, right? If I had a PNG on there, you would know that's an image file or a JPEG or a GIF, one of those things. So we already know about all these patterns in our head. In fact, our whole world is about patterns, right? If I hold this up, what's this? Smartphone. How do you know? I mean, this could just be a black piece of paper or something like that, but we all know that human beings are really smart, so we can look at that and say, I'm about 99% sure that's a phone, right? That's what that guy is. We can identify apples and oranges and all sorts of stuff, all right? So it might be handy for us to be able to describe at a significantly simpler level, because it would be very difficult for us to say, how do you tell the difference between an apple and an orange, right? Sometimes you get some apples that start looking pretty orangey, and you get some oranges that maybe look a little duller than some other oranges, and they might start from a distance and you squint a little bit looking pretty similar to each other. So what are the things, but as human beings we could probably still tell them apart, right? So what are the things that we look for? We don't actually think about that when we're identifying the piece of fruit in front of us, right? We just kind of know whether something is an apple or an orange. This goes back to like week 1 of class, where why is programming hard? We're so smart, we're so good at solving problems that we have trouble articulating how we solve them. All right? So regular expressions give us a mechanism for describing what I would call relatively simple patterns. So they give us a language for describing relatively simple patterns for matching things. So for instance, maybe an email address might be at least one character, followed by an @ symbol, followed by at least one character, followed by a dot, followed by probably exactly 3 characters, but now we're actually starting to extend that a little bit where there are some domains that have more than 3. But, if we were just to give you a generic definition of what a regular expression is, we might say it is, here's our next screen here. So if we have, we'll allow for there to be letters, and usually email addresses wouldn't start with a number, but let's just say that \W is what's allowed to be before the @ symbol. So I would say this guy right here is the regular expression \W. I need at least one of those things, followed by exactly the @ symbol. Okay, followed by, we'll say, at least one more word, followed by a period. And actually, I think we need a \period because period's a reserved thing in there. Unimportant for this little example. Followed by exactly 3 characters. Or we can say that. So it's a funky little way of describing the pattern for an email address, let's say. That's one way we might do it. Probably doesn't really perfectly describe email addresses because I'm pretty sure they can't start with numbers, things like that, but this is close enough. Go ahead.
In the book, all of the, every time it has an expression like that, there's an R before the quote.
Yeah.
Is that just part of the syntax?
It's actually not. So this falls into the category of make sure you do the reading, but if I was in your shoes, I probably wouldn't have read every single word in the book leading up to this. But in the strings chapter, remember last class, I think it was last class, might have been the one before, I showed you a formatted string, an F string. There's a type of string called a raw string, an R string. So if I have a string so a normal string, if I wanted to say LOL double quote hello, single quote, something like that, I would have to use escape characters in here for the single quote and the double quote so that they wouldn't get treated as string termination characters. Similarly, I can create a raw string. Let's see if it'll let me do a lowercase r there. And I could say LOL, hello, single quote, and that's fine. That's allowed. That says I will look at the beginning, I will look at the end, everything in between, I'm just going to treat it for exactly what it is, not try to interpret it. Yep. So as you imagine, so what he referenced there is in all the examples, it has the little R before the string there. We have a whole lot of backslashes and things like that in the strings for regular expressions. If we're dealing with those as in terms of regular strings, we can imagine that Python would start messing with our strings quite a bit, treating certain, like it would probably just yell at us that a backslash W isn't anything else. Why are you putting a backslash there? Because actually, in order to have a backslash in your string, you'd have to say backslash to actually have a backslash, because that's the escape character. So raw strings allow you to describe it a little bit easier. But if I didn't want to have this as a raw string, I mean, regular expressions do not require raw strings. Maybe that's the better way of putting it. So I would write backslash W, backslash, like that, to write the same thing, because I'm telling Python not to treat those backslashes as escape characters, instead treat them as backslashes. All right, so R means raw string. Okay? So our idea here is that a regular expression gives us the ability to express a pattern. All right, so he mentioned that, okay, one thing we could do then with regular expressions is we can, kind of give ourselves a structure for a pattern. But what might we do with that guy? Go ahead.
You can always search it to see if it has match it, or we can use a search function to see if it has a certain pattern.
Yeah, so I mean, we might care about whether something matches that pattern. Right? If my whole goal in life is to be able to identify email addresses, I can use this pattern, and if you give me any sort of input, I will say, yes, that's an email address, because I found a match for my email address pattern in there. I would say, no, this is not an email address. I didn't find a match for my pattern in there. That makes sense? This is pretty powerful. I'm going to show you an example here in a second of a use of regular expressions. So I'm going to quickly go through the solution for the homework today. Notice the book gave a hint, and I also wrote it in Slack, that that assignment becomes significantly easier if you just use multiple patterns rather than try to create this monster pattern that matches the world, right? So let's kind of look at that. So I'll go back into here first. So for is strong password, I gave you this code as a sample code up on Slack because regular expressions aren't necessarily difficult, but I wanted you to have a working code example since we didn't get to it in class. So you had that access to that. If you don't know what I'm talking about, check Slack more often. We put a lot of stuff up on Slack, including internship opportunities, and in the last 2 days, there's also some conference opportunities if you're interested in. So if you're not one of the people that check Slack, start checking it, because I've asked you to contact me if you're interested in going to one of these events. Go ahead.
So is the only point of compiling it then to increase the speed of how it runs, or is that how I didn't actually do that to make my program work?
Well, compiling it gives you results in. So if I come here, here's this is a pattern. So let's just go through this, and I'll kind of, when we get to the compile, I'll answer your question. So if I'm detecting whether something is a strong password, we looked at the rules in the book for what does it mean for a password to be strong. Well, one of the things is it has to be at least 8 characters long. All right. So what I said is we're going to have 7 alphanumeric characters followed by exactly 1, or at least 1 alphanumeric character. This will give me at least 8. There's some other ways you could have written this as well. I think I could actually put a 8 comma there and then leave this other part off, and that'll say at least 8 or more. All right, but I think this is pretty straightforward. I need 7 alphanumeric things followed by at least 1. The plus sign means at least 1 alphanumeric. So this will match 8 alphanumerics, 9, 10, 11, 12, blah, 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 whatever alphanumerics. When I compile this, so RE is our regular expression library. So I had to import our RE up here. So this is our regular expression library. I'm compiling this regular expression. Notice it's a raw string for convenience. So I'm compiling this regular expression, and what that is doing, this is a function. This function takes in a parameter. Given that parameter, it's going to return for me, not print, but return for me a value. I'm storing that value inside of this variable called at least 8 long regex. This is my pattern matcher to determine if a string is at least 8 characters long. All right, so compile is the function that returns that pattern matcher. That's what compile does. All right, so notice here I have 4 different pattern matchers. I have one to see if something's at least 8 long. I have another one to make sure there's at least 1 uppercase character in it. I put up on Slack to match uppercase characters. It's in the book, but I just brought attention to it. That says match at least 1. That's what the plus sign says. Asterisk says 0 or more. Plus says at least 1. Match at least 1 uppercase letter between A through Z. So as long as whatever I've passed in has at least 1 capital letter in it, I'll find a match. Here's at least 1 lowercase A through Z. Here's at least 1 digit. \D is the 0 through 9s. All right, so I have 4 different pattern matchers here. Is it long enough? Does it have at least 1 uppercase character in it? Does it have at least 1 lowercase character in it? Does it have at least 1 digit in it? All right, now I can use that pattern matcher and search within it. Here's another function. I pass it my potential password. This was the guy that was passed into my function here. And I'll pass the search function my potential password, and it will return a match object. This is something that has a collection of the matches it found, or more importantly for us, nothing, none, if it did not find a match. So if possible password was not at least 8 characters long, this guy will not find a match inside of possible passwords, and this guy will be equal to none. If it didn't have at least 1 uppercase letter, this will be none. If it didn't have at least 1 lowercase letter, this will be none. If it didn't have at least 1 digit, this would be none. So then I just ask the question, if any of those 4 things are none, if it failed any of my pattern matches, not a good password, right? Otherwise, I would only be in this else if it passed every single one of these things. If any one of them failed, I'm out. I'm dead. Okay? So that's when it would be a strong password. So that's what this function is for, is strong password checker, let's say. Go ahead.
Can you explain exactly what compile and search does?
Yeah, so compile, like we just said, was this guy. So this is a function, and this is a function. Just like we're writing our own function here, right? So we're writing a function here called isStrongPassword. Our function takes 1 parameter, and we're doing things with that parameter in here. Well, the regular expression library, among other things, has a function called compile, and it has a function called search. The compile function takes a string representation of a regular expression, and it produces for us, it returns a value. The value it returns is a pattern matcher. That's what he does. He gives us a pattern matcher. We don't have to worry about what that guy looks like. That's why regular expression was written for us. We went to Home Depot, we gave them our cash and our string, and they handed us a little box that I can drop strings into, and it matches patterns. All right? What does search do? Search is a function that belongs to a pattern matcher. So I just mentioned dropping a string into that box. Search is us dropping a string into that box. So that guy has a function called search that takes one parameter, a string, that is something I want to search within that string for patterns that match this regular expression. And what it returns for me is a group of matches. All right? So we've been writing our own functions. Now here's us using somebody else's functions. Go ahead.
I know what I did was I did re.search, and then I put in the pattern I was trying to match, and then the variable. And
Yeah.
that worked as well.
Yeah, so there's multiple versions of search. One that takes one parameter given a regular expression matcher. The other one you can give them both. Yep.
Use compile, so I'm guessing
It has compile built into it. You give it the regular expression. Internally, it's compiling it.
Okay.
Yep. The advantage of this is I might want to apply this multiple times. So I have my matcher. I can just use it left and right, but otherwise I can go off and just... for us, we don't care. We don't care how fast it is. So it's either one's just as good as the other. All right, so that makes sense what compile and search do. All right, these are functions that belong to somebody else's library that we're now using. All right, so if any of these fail, if I didn't find a match in any of my 4 checks, it's not a strong password. If I'm still kicking when I get to this else, that means it had at least 8 characters, it had at least 1 upper, 1 lower, and 1 digit in it. Must be a strong password. All right, then here's me testing it. This guy, not a strong password, right? Too short. This guy, 4, 5, 6, 7. Not a strong password, also too short. Actually, let me go ahead and I'll just make it a little bit longer. So now it's long enough, but also not a strong password because it didn't have any uppercase characters in it, right? This guy here is strong. It had uppercase characters and numbers. So there's not a strong password, not a strong password, strong password. All right, make some sense? Okay, so that is the code for the homework that's due today. And let me give you a...
So to be able to call to main, you have to have the if underscore name.
You actually don't have to put the if underscore name. You could just put main down there and just call it. This gives it some structure so that we kind of see that our program kind of begins here. And what are we doing? We're doing one thing. We're calling this function up here called main.
Okay.
All right, so let's say, just for the sake of time, I'm going to create a, so I gave you in the slides here kind of the cheat sheet from the book for all your regular expression stuff. Let's say we have given a string, remove all vowels. Something like that. All right, so what are our vowels? Our vowels are A, E, I, O, U, A, E, I, O, U. So those are our vowels, right? Upper and lower case. So if I have the string hello world, for instance, upper, lower case, whatever, and I wanted to remove all the vowels from that, my expected result would be HLL space W R L D. That's what I would expect my result to be. So if I asked you to write a function that removes all vowels from a string, remember, strings are read-only. So in order to remove something from a string, we actually need to build up a brand new string. So what we would do is we would keep non-vowels. That make sense? That's what we would do. we would go through every element of our string, each time through saying, is this a vowel? If it is, skip it. If it's not a vowel, keep it. Concatenate it onto a string as we're building up. Could we write that? Be a little bit tedious, but we could write that, right? Using the skills that we have right now. All right. But what we can do is we can give ourselves, let's zoom over on the screen. We can give ourselves a regular expression. So what's a regular expression for matching vowels? So a regular expression for matching vowels is going to be, I'll just go ahead and say my vowels regex is equal to, we'll make this a raw string. So all of my vowels are, we'll just keep it lowercase for right now, just to make this simple. A, E, I, O, U. Actually, I'll make it uppercase too. A, E, I, O, U. Except I promise I pressed that. All right. That's my collection of vowels. Right? All right. So now what I can do is I can go ahead and I can compile this, and then I can use a function called sub. And what sub will let me do is anything that matches that, it will let me replace it, substitute it with something else. Okay? So I can go ahead and say re.compile this guy. So right now, this guy will match a vowel. Make sense? And now what I can do is I can go ahead and I can say S is equal to hello world. Oh, thank you. S is equal to hello world. And then I could say something like answer is equal to vowels regex dot sub. I'm going to call it substitution function. And what I want to do is I want to substitute in S. Well, I think it's the string followed by what I want to substitute it with. The empty string. And then I can print out answer. 1 second. Oh, sorry. I'm matching at least one vowel. Oh, it's the other way around, like I said in the beginning. So I actually don't need to do this. It's replace it first, and then what am I replacing? So there's my hello world. So I said this regular expression here will match anything that's a vowel. Here's a string that I might want to remove vowels from. What I can go ahead and do is I can write a function here called like def remove vowels and have this guy take in a string as a parameter. And this guy will take in a string maybe called S. And I'm going to say I want to substitute in S any vowel with nothingness, an empty string. And then I will return answer. So now down here I can say S is equal to hello world. Then I can say answer is equal to remove vowels of S. And then I can print answer. And there's my hello world. Oh, I had already printed answer twice there. But notice that I can now call remove vowels on any of my strings. I'll just pass it a different string here. And then remove all the vowels from that guy, and there is that string with all the vowels removed from it. So we see the power of regular expressions in that we could write the code to remove all the vowels from a string by going through, asking a bunch of questions, looping through every element of the string, things like that. But with regular expressions, I'm able to leverage this tool, this function called sub, that lets me substitute within a string something for all things that match this regular expression. If I didn't want it to be an empty string, I could substitute it with question mark, LOL, question mark, or something like that. And you'll see our response has a bunch of question marks, LOLs, question marks in it. All right. Questions, comments, concerns, bribes. All right, so we will not meet on Friday for normal class, but I invite you to take the exam during class on Friday when we would normally have the exam, or take it at any point before midnight on Sunday. And the homework that was due on Friday is now due at midnight on Sunday, and I'll do something with the homework for Monday. All right, I will see everybody, and I'll put this code up so you have something to reference, because your homework for Sunday uses this sub thing. One second, let me get this.